Okay guys, so this is going to be our last lesson over factoring example problems. So we're going to go through this quickly. So the first example problem is going to be a difference of squares. So square root of x squared is x. Square root of 324 is 18. Going back to what I said earlier, you need to make sure that you know all your squares through 25. Okay, it's useful. This is going to be another example of difference of squares. So square root of 1 is 1. Square root of 625 is 25. Now, this difference of squares is pretty much the same as this, but the terms are just reversed. So don't freak out over that. Get this coffee cup out of the way so it doesn't have a shadow. Okay. Factors of 10 that add to 7 are 5 and 2. So this is x plus 5 and x plus 2. Factors of 8 that give you a negative 2. Okay, so they both have to be negative. So negative 4 and negative 2 don't give you, they would be a negative 6. So this should be does not factor. Okay, so there's no factors of 8 that give you a negative 2. Factors of 16 that give you 4. So factors of 16 are 1, 16, 2, and 8, 4, and 4. So none of those are going to give you factors of 16 that give you 4. So this is going to be does not factor. And sorry if I'm scrambling for words. It's late at night and I'm doing this video. Okay, so this next one, what I would do is I would factor on negative because we always want our leading term to be negative. And I'm going to rewrite it in descending order. Okay, so remember when we factor on negative, we change all the signs. So factors of 15 are going to be 5 and 3. So sign in the middle goes with the larger factor. So that's what it looks like. Next one, they all have a GCF of 3, so let's factor that out. Minus 6x, ooh, 4x. And 36 divided by 3 is going to be 12. So factors of 12 that give you a negative 4 are going to be 6 and negative 2. So x minus 6 and x plus 2. Remember that the sign in the middle goes with the larger factor. I think I said that wrong. Factors of 12 are going to be 6 and 2. So in order to get negative 4, it's going to be a negative 6 and a positive 2. Okay, the next one. So looks like they have a y squared in common. So let's factor out a y squared. Okay, so our factors of 30 that add to 11 are going to be 6 and 5. Oh. So 6 and 5. And that's all there is to that one. GCF between 4, 12, and 9, there's not one. So let's do PSF on this. So your product is going to be 36x squared. I feel like we already did this problem. Your sum is going to be 12x. Your factors are going to be 6x and 6x. Okay, so we get 4x squared plus 6x plus 6x plus 9. GCF there is going to be 2x and 2x plus 3. And GCF there is going to be 3. And so we get 2x plus 3. So this becomes 2x plus 320 squared. Next one, if we're going to do PSF on this, your product is going to be 3x squared. Your sum is going to be 4x. So the factors of 3 that give you 4 are going to be 3 and 1. So when we go to break it down, going to look like this. GCF here. And your factor, GCF between those two terms is 1, so it's x plus 1. So this becomes 3x plus 1 and x plus 1. Okay, this is going to be difference of squares. Difference of squares. Okay, so anytime we have an even power, we can use difference of squares. So the square of the first term is going to be x squared. Square root of 576 is 24. And x squared minus 24, like that. Now, even though 24 is not a perfect square, I just want to kind of show you this real quick. I don't care if you break this down. X squared plus 24 doesn't break down, so don't bother with that. That's sum of squares, never factors. Now, this could be x plus square root of 24 and x minus square root of 24 if you ever see it like this. I just want to show you that you can break stuff down even though it's not a perfect square. Okay? And if you want to factor, write this as 2 square roots of 6, 2 square roots of 6, that's okay with me. Okay, either answer I'll accept. Okay, next one. X to the 6 minus 2x cubed plus 1. Okay, so your factors, your product on this one is going to be x to the 6th. Your sum is going to be negative 2x cubed. Okay, so factors of 1 that give you a negative 2 are going to be a negative x cubed and a negative x cubed. Okay, remember when you multiply exponents, you add them. So negative times a negative gives you the positive 1. X cubed times x cubed gives you x to the 6th, and they both add to negative 2. So when we go to break this down, okay, so this is x cubed and x minus 1. They have a negative 1 in common right here. Sorry. Okay, so when we go to write this out, this is going to be x cubed minus 1 squared. And this follows our pattern. You square the first term, x to the 6th, take the 2 in the middle and double it, square the last term. Okay, GCF here between x to the 7th and x to the 5th is x to the 5th. Like that. And you can break that down by different squares. Okay, so that's what that factors to. Factoring by grouping. So we get x squared times x plus 2. They have a negative 1 in common, so we're going to break that down. So we get x squared minus 1 and x plus 2. Different squares will factor again, so x plus 1, x minus 1, and x plus 2. Next example problem. First two terms have an x cubed in common. They have a 1 in common. So when we go to factor by grouping, it's going to look like that. Now, we know that sum of cubes can factor down. So your a is going to be 1, your b is going to be 1. So this is going to be a plus, oh, sorry. Your a is x, sorry, x. So this is going to factor to x plus 1 times x squared minus x plus 1. And don't forget the x minus 1 over here from that. Okay, now the last two problems are going to look a little bit different from what we've done earlier, but it's just a GCF. Okay, so each term's got an x plus 3 in common, so I'm going to pull it out. And I'm left with an x and a negative 6. Same thing here. Each term has an x plus 2 in common, so I'm going to pull it out. Now you see, when I do x plus 2 divided by x plus 2, I'm left with an x plus 2. You don't have to keep the parentheses when you do that. Now, when I divide x plus 2 divided by x plus 2. I'm left with a negative 5 right there. Now I'm going to combine my like terms. And I get x minus 3. Now you have a homework question that's looks super complicated whenever you start doing these. So you need to go term by term and factor out your GCF. Okay, so this has been factoring, set number 3 examples. Make sure when you're factoring that you pull out GCF first, and your leading coefficient is usually always positive. We're looking for difference of squares, sum of cubes, difference of cubes, that sort of thing. What I've noticed over the 11 years I've been teaching is that people don't know their multiplication facts, and that is why factoring is hard. So we need to make sure that we know our multiplication facts well enough to be able to not use a calculator on this stuff. And if you think I'm going to let you use a calculator on this stuff, you're dead wrong. So make sure you know your multiplication facts. This has been factoring set number 3 example problems. Thanks, and have a good night.